All right, welcome to Algebra Chapter 6, Section 6. Easy for me to say. Today we're going to be doing systems of linear inequalities. It's kind of like systems of equations, meaning that I'm going to still graph two lines, but because they're inequalities, I have to decide, are they dashed or solid, and which side do I shade on? And we're going to talk about all of that in just a minute. So make sure you have that in your table of contents. And then flip over to page 64. Now I'm going to be working on this handy dandy half sheet of paper. So systems of linear inequalities. Okay, I'm having a hard time writing on that, so I'm going to glue this in just a minute. So I'm going to go ahead and put this over here so it's easier to write. There we go. Systems of linear inequalities. Okay, so the first thing we're going to do is define it. So a system of linear inequalities is a set of two or more linear inequalities containing two or more variables. Okay, so we're only going to be doing two at a time, which is going to be, much nicer than if we were trying to do more than two. So the solution to a system of linear inequalities consists of all the ordered pairs that satisfy both inequalities. And another way to look at this is it's where they overlap. So if it's just a system of equations, there's equal signs, it's where the two lines cross. But if it's an inequality, it's going to be where they overlap. So let's look at an example of this really quick. So if I have this, y is less than or equal to negative 2x plus 3. And I'm going to do them in different colors, so hopefully it's a little easier to see. And then y is greater than 1/2 x minus 2. All right, so if I come over here and I draw a handy dandy graph, and I try to be as precise as I can with all my little markings. That's, I think, the hardest part is just keeping, all your distances equal when you're hand drawing it, at least. All right, so I can do this a couple of ways. So if I use my handy dandy calculator, I can go to my y equals, clear out whatever's in there, and I can just type in negative 2x plus 3, this is probably how you're going to do it. Then I'm looking at the table. Now, obviously, I don't want anything quite this big, so I'm going to go backwards. And so I have -1, 5. So -1, 1, 2, 3, 4, 5. I have 0, 3. So 0, 1, 2, 3. 1, 1. And let's see, 2, -1. 1, 2, -1. All right, so I'm going to get some dots and I'm going to graph them. Now, I need to look at this symbol and say, is this going to be solid or dashed? Okay, remember, if it's got the line underneath it, it's solid. So this one is solid. Then I need to decide, am I going to shade above or below? Now, since y is less than, I want to shade below because that's littler than. So here I am shading below the line. Now, I'm going to go back in and I'm going to erase that and I'm going to type in my second line, 1/2 x minus 2. And once again, look at the table. Now, I'm not going to pick the ones that have like crazy fractions. So like -2, -3, I can do that one. So -2, -3 is right about there. 0, -2. 2, -1. And 4, 0. 1, 2, 3, 4, 0. Okay, so I have my dots. So I put my 4 dots on there. Now I need to decide, is this solid or dashed? Well, you see this one does not have the or equal, so it's going to be a dashed line. Now I need to decide, am I shading above or below? And it's y is greater than. Greater than is going to be on this other side. So I'm going to shade above it. And you'll see that the solution is this area that's the double overlap, where the pink and the purple both are. So this is the solution, and it's all of the points in this area. Over here, it can be on the line because this is a solid line. On this one, because it's dashed, it cannot be on that line. But any of these points, so 0, 0 should be in there. -3, 3 is in there. -8, 2. -8, -2. So all of those, anything that's going to be in this double shaded area, it is a solution. So that's how you're going to graph the systems of inequalities. And that's really what they should look like. So I'm going to glue this page in over here. But there are some exceptions to this rule. I mean, as far as if it was all just nice and neat and easy like this, then, you know, there we go. This is, however, is when they have parallel boundary lines. And this is just something you need to be kind of aware of. So I'm going to split all of this into thirds-ish. And I'm going to do 3 different, examples. So if I have this, y is less than 2x minus 3, and y is greater than 2x plus 2. So I'm going to graph these. So the first thing I'm doing is, of course, just drawing my grid so it's nice and easy to graph the points. Obviously, on your classwork, they will already be there. The next one I'm going to do, and I'll come back and actually fill this out in a minute, is y is greater than x minus 3, and y is less than or equal to x plus 1. So and the last one is going to be y is less than or equal to negative 3x minus 2, and y is less than or equal to negative 3x plus 4. And hopefully you can tell on all of these, because if you're looking at the slope, remember, if the slope is the same, then you know they're parallel. Okay, that doesn't change just because it's an inequality. So the first thing I'm going to do is get all of this set so I can just come in and throw some points on here and graph. All right. So I'm going to do the top line in pink up here in pink and the bottom line in orange each time so that we can kind of see what they look like. So once again, I'm going to come to y equals and I'm going to go 2x minus 3 and I'm going to look at the table. And I'm going to pick some points. I could do -1, -5. So -1, 1, 2, 3, 4, 5 is there. 0, -3 is there. 1, -1 is about there. 2, 1 is about there. 3, 3. I could keep going. So you get the idea. 3, 1, 2, 3. There we go. And now I have to decide, is this solid or dashed? There's not an or equal to, so I'm going to dash it. Now I need to decide, am I shading above or below? And this is y is less than, so it's below. So I'm going to shade down here. So you're really just solving these exactly the same way. You'll just notice that it's something a little bit weird. Now I'm going to do the bottom one. So I have 2x plus 2, and I'm going to look at the table. So I have -2, -2, -2 is about there. -1, 0, 0, 2, 1, 4. All right. Once again, solid line or dashed. So it's just a greater than, so it's going to be a dashed line. And it's y is greater than, so which side do I shade? I shade on this side. So if I know that the solution is where they overlap, hopefully you can see that there is no overlap. So for this one, there would be no solutions. All right. So that's the first possible case when you have parallel lines. Now the second one, if I come here and I go x minus 3 and look at the table, so that's the first one. So I'm doing the first ones in pink. So I have -2, -5. 1, 2, 3, 4, 5. -1, -4. 0, -3. 1, -2. 2, -1. All right, so that's enough. This one, solid or dashed, is going to be dashed. And do I shade above or below? It's y is greater than, so I'm shading above. All right, so now I'm going to do the second line. So it's going to be x plus 1. Look at the table. So I have -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. So now I'm looking, is this solid or is it dashed? Well, there's the or equal to, so it's going to be a solid line. And do I shade above or below? Well, it's y is less than, so I'm going to go where the less than is, which is below. Now, hopefully you can see that the overlap is going to be this area that's between the two lines. All right. And so I'm going to write down here the solutions, because there's more than one, are any point between the parallel lines. And I'm going to abbreviate parallel. Hopefully you understand what that means. Okay, so that's case number 2 when you have parallel boundary lines. Now let's take a look at this last one. So negative 3x minus 2. Look at the table. So this is my first line. I'm doing it in pink. So I have negative 2, 1, 2, 3, 4. Negative 1, 1. 0, negative 2, 1, negative 5. All right. Now, is it solid or dashed? Well, it's an or equal to, so it's solid. Oops, line's a little wonky. That's okay. Am I going to shade above or below? I'm going to shade below because it's less than. Okay, so that's line 1. Now let's look at line 2. So I have y equals negative 3x plus 4. Looking at the table, 0, 4 is there. 1, 1. 2, negative 2. 3, negative 5. All right, once again, solid or dashed? It's solid. And am I shading above or below? It's actually going to be below. So where is the double overlap? The double overlap is going to be right here. But you can see it's actually just the same answer as one of my 2 lines. That second line didn't really matter. So the solutions are the same as y is less than or equal to negative 3x minus 2, which is my first line. So I can either, if I have parallel lines, I can either have no solution, any point between them two, or just the same solutions if there was only one of the 2 lines. And those are all the special cases. So, all right, make sure you have these down, take care, ask questions. And the next answer is Bugs Bunny. See you next time.